I am on the contractor side to arrows on LANDFIRE. I've been with LANDFIRE about 8 years now, and I love it. I work on vegetation and recently been um, the technical lead, but still kind of have one foot in each realm for the time being. I'm excited to talk to you today about LF 2023, our update that is currently coming out this year, some of the new methods that we have, improvements and innovations that are coming into play. All right, so here's a list of some of the improvements in LF 2023 update products. So we revamped how we create our satellite image composites, and we broke the year up into 4 seasons as we shifted to fiscal year from calendar year. And the benefit of that is just better capture of disturbances. So that's an improvement. We are, for the first year, 2023, we are mapping disturbances in that 90-kilometer buffer from CONUS into Canada and Mexico. We have 2 new types of annual disturbance products, limited and preliminary annual disturbance, and I'll touch on that briefly here in a minute. We have new fuels calibrations for the Southeast geo area. That's the entire geo area. That one's really extensive. Also the state of Colorado and a portion of Oklahoma. So those are improvements to our fuel model assignments. We have an updated operational roads product for CONUS with the update from NLCD 2021. The return of standalone fire regime products that were nested within BPS previously. So that's fire regime group, fire return interval, and percent fire severity. People thought those went away. They went into BPS attributes, but now we'll be breaking those out. We have an updated BPS product coming for Alaska, an updated fuel characteristics classification system product for all extents. And we're using machine learning to update existing vegetation cover, height, and type within CONUS. And that's what I'll spend the rest of the presentation talking about. So a lot of exciting stuff happening, and we came off of a big push to annual updates. And so now we're continuing to make advancements with each update cycle. So here are our 3 annual disturbance products. I just wanted to touch on this because it's quite a bit of a change. So previously we've had 1 annual disturbance product, but we really were being, we really wanted to provide that information as soon as possible and also as complete as possible. So that's why we have 3 now. The first limited annual disturbance product comes out as soon as we can get it out. That's in January. So this is the first year we did that. It includes the events and fire program perimeters obtained from national sources. We don't have time to incorporate any satellite change detection or image-based severity assignments. So, but that, is already getting used primarily by risk assessment folks. We have the preliminary annual disturbance that comes out with each geo area, and that's really similar to the product that we've provided in the past. It includes the satellite change detection, image-based severity, in addition to LDIST. That is our first poll of events and fire perimeters, and that's really early in the year. That's in the October of the previous year, and not everything is in yet from the different agencies, and there's a lot of work that goes on past that date to get fire perimeters and all of that mapped and everything. So we recognized it's not a complete picture, did some analysis, and there was a lot missing. So we decided to do a second poll of all those sources for events and fire perimeters in the middle of the year. So right now we're doing it in June. And that all goes into our final annual disturbance product to complete the record. Too late to be used in our current production cycle, but it will be used in future years because we stack 10 years of disturbance up for vegetation and fuels updating. So it's a way that LANDFIRE is responding to different user needs, and that was what we came up with for doing that. All right, so shifting topics here to our second kind of main topic is that LANDFIRE 2023 uses machine learning to update vegetation. So LANDFIRE was founded on the use of machine learning to create detailed vegetation maps for all lands of the United States that was used to create fuels products. The first base map, which was also called national, was circa 2001, as updated using rule sets, because that was the most feasible given the large amount of time needed to model vegetation with imagery. Couple examples of these simple rule sets: a high severity fire or harvest would change from tree to herbaceous cover, or a low severity thinning would reduce tree cover, by 50%, or they're really they're not empirical based. They're basically expert opinion. Well, eventually there was a need to remodel vegetation across the board. So a second base map to accurately capture current ground conditions and leverage technological advancements in remote sensing. This second base map was circa 2016. It's also called remap. All pixels were updated, were remapped using machine learning. Supervised classification, current satellite imagery, training plots, field plots, LiDAR. And after that came out, this map was updated again with rule sets. So during this time, like I mentioned, one of our big goals has been to move to annual updates. So we want to increase our frequency to annual updates, and we also wanted to reduce our latency to the previous growing season. That was no small feat, but we have accomplished that. Starting with our previous update, came out the year after, and represents previous growing conditions, previous growing season conditions. During this time, another goal has been to incorporate these base map methods into our update process. And this has led to a new technique for updating vegetation in LF 2023. What I'm calling update with modeling. It's still an update because we're only making changes in disturbances, accounting for those, adjusting vegetation. But instead of using these rule sets, we're using the same machine learning methods from a base map to predict existing vegetation with current satellite imagery and training data. So that hopefully gives you, a little history lesson, kind of where we've come, where we're at. So this sort of shows you, we had to start with a purpose. We had some planning, some substantial prototyping, and now here we are in production. So it's been a long road to get to where we're at. As we were finishing remap in 2021, around there, and falling back into update cycles, we saw an opportunity to replace those rule sets with modeling, given the imagery, the satellite imagery was more accessible than ever, and all the advancements we made with remap. We had all these scripts, this whole process set up, and the imagery was on the shelf. And we thought, well, let's try to use it for our update process. So it's really where the idea started. We set out to develop this process and test our ability to model vegetation and disturbances with the hope of implementing for 2023. And we have been able to accomplish that. We spent about 2 years prototyping in different geographic areas as a parallel effort to our current production work. Did quite a few assessments on those prototype products and found that the modeled results were indeed more accurate to ground conditions than rule sets, as you would expect, since it's based on imagery. We looked at, we have the ability to model all pixels. So we asked the question, well, we could update just 10 years of disturbed areas. That's what's used currently in our, has been used in the past just for the updates. But we knew that a lot of those areas that were disturbed previously have grown back. There's been a lot of change there. So we doubled that and decided to update 20 years of disturbances with this method. And there really were two main advancements that made us believe we could compress what took almost 4 years for remap into 6 months for an update cycle. The first was new percentile-based image composites using harmonized Landsat Sentinel that produces smoother imagery with less artifacts than what we used previously for remap. We no longer have to manually clean them like we did for remap. So that was a substantial effort that we're getting around now. And we think that's what made us think, well, maybe we could do this on an annual basis. And the second advancement was creating automated methods for generating model training data using consensus map sampling that significantly reduced the time needed for us to add manual desktop plots specifically for lifeform modeling. So that was, another reason remap took so long, and we really honed in on those two areas to try to speed up the process, and we did. All right, so this slide kind of gives you an overview of the process. What we're doing is first modeling the dominant life form for every pixel. So are there trees present? If not, are there shrubs present? If not, is there herbaceous vegetation present in that order of hierarchy? We are modeling EVC and EVH using the same 4 seasonal image composites as those used for disturbance mapping. For remap, we made separate image composites, and we really didn't have the capacity to keep doing that. So we put our heads together and agreed on, what date ranges and parameters do we need to set for creating those image composites so that both of us could use them. And we're using field plots from the LANDFIRE reference database, or LFRDB. We have thousands of new plots that we've added since remap, primarily from BLM, AIM, and also from FIA, those two main programs. And we're also using JEDI LiDAR for tree height. So it's a spaceborne LiDAR. We haven't used that before, but really found it fairly available to incorporate into our process. There has been a lot more airborne LiDAR available as well, but a lot of the tools have changed, and the process where that's stored has changed, and we are still working on a process to incorporate airborne LiDAR data. So right now, this year, we're, for tree cover and shrub herb cover, we're using our field plots. But with the addition of all those plots that I just mentioned from BLM and Forest Service, that has really improved our models to the point where it's equivalent or better than our models from remap. So the third vegetation product is EVT, and we are updating that to match the dominant life form from these modeled results. And we're using the models from 2016 remap. We haven't, gone to the point of figuring out how to model EVT faster, on this type of time frame, but we're planning to look at doing that in the future. EVT vegetation type modeling is just so much more time intensive than structure. So that's why we looked at structure first, sort of lower hanging fruit, to try to model more rapidly like we're doing. Right now, it's only for CONUS. We're planning to expand in the future to other areas. And then there's the fuels piece that we spent quite a bit of time on trying to figure out. The fuels is using the modeled results for disturbances 11 to 20 years ago, because they treat all of that as with a set of rules for non-disturbed. They only treat disturbed areas as 1 to 10. We plan to look at, you know, look at a way moving forward for fuels to use the model results for 1 to 10 years, but right now they're using their traditional rule sets that they've used in the past and equations for canopy. So that's consistent with what they've done in the past. So we encourage your feedback, you know, as you work with the products. You know, we're interested to hear, you know, what you're seeing. We're looking at the results and we're encouraged, think they look good. And so excited that this has panned out. Of course, there's, you know, been growing pains and questions as we move forward, but, you know, I'm sure we'll get that sorted out as we go. So that is all I have. Thank you for listening. And like Megan said, check out our new website. So yeah, at this point, we'll open it up for questions.
Thanks, Daryn. Jenna had a question about the training data. What is the training data used for disturbances?
Yeah. So identifying the disturbances as a whole process. We have a team of disturbance mappers that sort through that information. We've got automated a couple algorithms to look at pre-disturbance and post-disturbance imagery to map, you know, the extent of the disturbance and also the severity. And they do get training from known past disturbances to train a model for mapping disturbances in current year imagery. So that's what they use for training for those models.
I'd also like to put a plug in for a video that one of the disturbance mappers and I made just in the last month or so, and it's called A Day in the Life of a LANDFIRE Disturbance Mapper. So once I find the link, I'll stick it in the window, but it's a fun, I use the term loosely fun, 10-minute video that talks about how do you go from aerial imagery and all of this machine learning training data and get to the final product. So I learned a ton making the video, and I think you all will too if you check it out. So Inga has a question or maybe a contribution.
Yeah, hi guys. Can you hear me okay? Okay. So I'm not sure if this is what the commenter meant, but in terms of training data for vegetation mapping and those disturbances, I think that might be what they were talking about, because there was a follow-up comment about how there's not a lot of disturbances on FIA plots. So I think it's important to realize that one of the cool things about JEDI data is that it is in disturbed areas as well. And so I think for the rest of the training data, you know, the hope is that we have enough variation in you know, ages of the vegetation to be able to capture that early successional life form cover and height in those disturbed areas. But yeah, I always want to put a plug out there for folks to be gathering more post-disturbance vegetation recovery data because we need that for training, right? So yeah, I just want to put that plug out there as well.
Hey, this is Gina. I'm the person that asked the question. And yes, Inga, I was trying to get at the disturbance, but I also asked it before Daryn then addressed it. So I feel like I should have just waited, been patient. But yeah,
okay.
He was talking about that. So thank you.
Yeah.
No, it's a really good point because, you know, we're creating these models with non-disturbed training data and then applying it to disturbances. And that's, you know, is a challenge, but, you know, it comes up with reasonable results, but it's definitely something we're hoping to improve on.
I'll put the link for if folks want to contribute disturbance and treatment polygon data. I'll put that link in the chat window so folks can read through how to provide this sort of information so that it can be included in future updates. Robert Zeke has a comment. This new approach seems to align well with hierarchical classification systems. Do you see this encouraging the transition? Do you see this encouraging transition to this approach to classification?
Yeah, no, that's true. Because yeah, we've had ideas there. This is how we did remap a national. Actually, we identify the dominant life form for each pixel using a classification tree. So it's a thematic map. It's not based on, aggression or percent cover, which, one would think we might be doing it that way, but it's really difficult to do it that way. And we find it much more feasible to do it by classification. And then, like, let's say that model said the pixel had tree cover, then we bring in the tree cover and height information into EVC and EVH. So this is how LANDFIRE has been. This isn't a change. This is how LANDFIRE has been doing it. And yes, that is a hierarchy. It doesn't always align really well with that national vegetation classification system. That is a hierarchy as well. And I think there is opportunity to sort of align, but that's, I guess, something we'll be looking at in future years. At this point, we haven't looked at it closely currently. But yeah, the EVT that the fuels uses is ecological classifications, and we have to sort, one of the first tasks when we go to map is sorting through all of those and identifying them as, are they going to be in the tree model, the shrub model, or the herb model? And that's not always clear because some of them really can be either. And the same is true for the national vegetation classification.
And the second part of Zeke's question, do you see mapping of tree versus shrub versus herb cover facilitating better classification of veg and fuel in disturbed hours in years 1 through 10 and years 11 through 20?
Yeah, the more recent the disturbance, the more difficult the modeling is, just especially with fires. When you have the reflectance is so different in those areas. The model hasn't seen anything like that. So especially like recent fire scars, it's tough. That's where we put in the pseudo plots because, like Inga mentioned, we don't have any field plots in those areas, or not enough, maybe 30 or something like that. But we need thousands. I would say, the year after is the most challenging. That's where we add the pseudo plots. Another couple of years after, that's still where those pseudo plots come into play. Once you get to 2 to 3 or 4 years out, and that the really charred earth coming through and the reflectance is starting to go away, and the vegetation is giving the dominant signal, then the model is more reliable. And certainly 11 to 20 years out, that's going to be really reliable. But we didn't break it out, with it. We did a little bit of that, and some of our assessments did back that up. But yeah, that's definitely what we're seeing.
You used a term pseudo plot. I might have missed that. What's a pseudo plot?
Yeah, that's plots that we just add based on aerial photos or the expert opinion plot or desktop plot. But we really have to rely on those when we don't have adequate field data to do this mapping. So yeah, it's just a reality, of it. It's still based on imagery, but the training data aren't from the field. We don't do that for cover or height. Of course, we can't really assess that with aerials, but for determining if there's trees or shrubs present, we do that.
Jim asked, are there efforts in place to map all pixels, not just pixels disturbed in the last 20 years?
Yeah, I don't know if Henry mentioned it, but there's been this term kind of floating around since remap. Remap was a really big effort. There's a lot of planning, a lot of resources went into it, and we accomplished it. And now the question has been, is that really the best way to get a new base map? Is, so many. Is there a way to maybe bite off smaller pieces and do it more on a continual basis, so that we can sort of manage it? It's more manageable, and we don't have to, for example, hire staff and then let them go when it's done, sort of thing. So yeah, we are looking at this as a stepping stone, we believe, to remapping all pixels again in the future, but it probably will. It's looking like it'll be different than every 15 years creating a new base map. But we don't have any details at this point what that'll look like. But we definitely have the capability. I mean, right now we're modeling all pixels. We're just choosing to bring them through in those recent disturbances, or 20 years of disturbances.
Thanks,
Daryn, I've got a couple technical questions that I hope are hopefully are helpful for everyone. First, when you label a pixel for life form, you go into that a little bit more. So, for example, I'm imagining a pixel that's kind of savanna-like, where it has maybe one tree and a fair amount of herbaceous veg, versus, northern hardwoods, where it's continuous canopy of trees. How do you decide whether a pixel is tree, shrub, or herb when they're often mixed?
Yeah, good question. So if there's greater than 10% tree cover, we call it a tree pixel. If there's not, and greater than 10% shrub cover, call it a shrub pixel. And if not, then if there's greater than 10% vegetation period, it's herbaceous. And if it's less than that, then it's barren or sparse. So that's our definition, and that's really what we're shooting for. But again, we don't use our cover models to make that designation. We have a classification model, and we go through our LFRDB plots and apply that logic with the 10% rule. And that's what we use to train that classification tree model. Yeah, there's different models that we try to see which one's better. But that's how we do it. And then that's, as when you look at our products, the vegetation type, cover, and height, they have that life form mask, so to speak, identifying where we have like tree cover will match between a tree pixel in EVT will match a tree pixel in the cover and height products. Yeah.
Thanks for that. And one more technical question. And so the other day I was summarizing LANDFIRE existing vegetation type, height, and cover data for the Great Lakes Basin. A really cool project, and it's so cool. I'm still thrilled we can do this stuff because of LANDFIRE data. It's really cool. In the EVT, I found that it was roughly 30% ag types across the Great Lakes Basin. And then when I looked at cover and height, it was more like 22%. And so I was a little confused at first, and I started digging in. And it looked like it was a burnable ag issue, but not having the expertise. So I wanted to ask, and I didn't see it. Maybe in the technical manual, which maybe we can put a link to that too, which is really cool. But it looked like row crops, which I imagine soybean, corn, was labeled as ag in the cover and height data sets, whereas pasture, haylands, which to me seemed like, oh, that could be very burnable, was given a herbaceous label instead of ag. But I wonder if you could address that a little bit.
Yeah, I can see how that tripped you up. So we have burnable ag types like pasture, hay, orchard, and then bush fruit and berries, and then idle croplands as well. We give those a modeled cover and height, oftentimes herbaceous, but tree if it's orchards, and then shrub if it's bush fruit and berries. And, we could split those out, designate them differently in cover and height, but we just, they're given they're not separated out. Like you said, they're, you'd have to look to EVT to identify the burnable ag types. So it's a feature of the data, but yeah.
Once I dug a little bit, I thought that was the case, but I wanted to get confirmation today. And
Yeah.
it was cool.
No,
I
it's a
got
good
it once
point.
I
We could,
thought about it a little bit.
yeah, we could make that more clear in the technical documentation or the metadata. Yeah, it might not be. So I'll write that down. Might not be as clear as it could be.
Great. Thanks, tons. And with that, I'll turn it over to the rest of the group for all questions, LANDFIRE. We're happy to jump in and try to help.
Brian, will LANDFIRE help map old growth areas?
You know, Brian, I can jump in, but please encourage others to help. Okay, so I've been addressing this question a little bit on my end. So, and I'll start with a disclaimer. My views may or may not represent those of LANDFIRE more broadly. So to me, when I think old growth, I think about some micro characteristics. You know, if you're in old growth northern hardwoods in the lake states, that might be those really gnarly yellow birches with tons of texture in the bark and, you know, really micro sorts of things that are super important for biodiversity. Then, you know, I kind of broaden it out. So LANDFIRE maps a concept called late succession in the succession class data sets, which are tied to the biophysical settings, which is sort of a, for lack of a different term, I think the easiest way to think of it is like an ecological footprint. So if you have an ecological footprint of an ecosystem type, say northern hardwood's a favorite of mine, where do you find trees that are, quote, late succession as defined in our biophysical settings, descriptions, and models? So we can model expert-driven late succession, but that is a very blunt hammer. And I would say it does not get at old growth, which to me, again, gets at more of those really cool, you know, how mossy is it? What does the bark look like on the trees? How much coarse woody debris is there? And all those things vary from ecosystem to ecosystem. So I would say LANDFIRE can help map late succession as a crude first approximation. But yeah, I would love to hear others. I'm guessing, Daryn, you've thought about this. Inga, others have thought about this. So I would love to hear other viewpoints on it. Great question, by the way, Brian. Thanks. As I mentioned on the very end that, you know, late succession, old growth, those concepts vary from ecosystem to ecosystem. One thing that's cool about LANDFIRE is that we distinguish between open late and closed late. Again, it's a blunt hammer, expert driven, but that is super important in my mind because we don't want, you know, I don't want to just say late succession, because late succession in a fire adapted ecosystem where you might want or have had historically a lot of that open late succession. Think ponderosa pines around northern Arizona, which would have been widely spaced, big trees, open canopy, would be very different than some of the closed canopy, which may not have been very representative on the landscape in some of those fire adapted ecosystems. So I just want to throw in that note. Again, it's a very blunt hammer. LANDFIRE is not designed for mapping old growth, but we can help get you started in my mind. But again, love other thoughts on that.
So I'll jump in. I think Randy's hitting on some definite aspects. I'll make a tie to the last open office hours that we had where we talked about, you know, the classification. And there's definitely a desire to make some improvements. Of course, not only just with the National Vegetation Classification Standard, NVCS, that will, I think, be important and help to what you're talking about, Brian. But we are also taking a harder look to see if there's things that could not be done relative to classification around dominant, codominant types, and then leveraging the extensive plot database that LANDFIRE has. We've got like over 1 million plots now as you look out across all the various databases that are there, that I think there is a potential there that could help inform old growth areas, specifically, you know, tying these various pieces together and do it in a way that you'd leverage, you know, kind of a dominant codominant relationship of the vegetation. So more definitely needs to be done in that realm. Nothing that's available that you can use today, but it's definitely something that is being discussed and thought of how to potentially approach this. So I share that in the context of what might come, and then I really appreciate Randy's comments around BPS, ESP, because there are a lot of products there that you can think about on how to adapt and apply them to a question like that.
And Inga adds, if you have criteria for height and cover for what old growth is in your veg type, you can use LANDFIRE data for that. So that can be helpful.
So I'll add one. You kind of alluded to this, I think, in both what Daryn mentioned and the prior comments about the issues you were finding, Randy, with non-burnable. Okay, so that's definitely been an item that LANDFIRE has been chasing for a long time to try to make improvements in that realm. So the things that you alluded to, Randy, about, hey, I'm seeing some problems here when I look at these various cropland pieces, and I appreciate what Daryn had to say about how we take information from the National Agricultural Statistics Service with their cropland data layer and then break things down. And so that's been, I'll say, the largest step to help address some of that. With that being said, there's still more work that needs to be done. There are some scientists that are working to look at, I'll call them, because let's be honest, agriculture is just another vegetation type, right? I'm going to call it more an actively managed, type vegetation versus what you might see in some other forested systems. So there are some scientists that are looking at agricultural types and thinking about the burnability of that. So that's a side, and so it's great to say, hey, scientists are doing stuff. I do think, though, with the cropland data layer classification, to what Daryn was talking about of the various categories, there are some things that could be done to further tease out the various relationships. So what I'm going to refer to is, for instance, we know that like a wheat field or a cornfield and things like that, given the seasonality, and LANDFIRE is doing quite a bit of good work in the Southwest Great Basin as well as the Southeast relative to seasonally adjusted fuels based on environmental conditions, drought, precipitation. And so those are really good products, but I think we could take that same kind of methodology and thinking and apply that to some of these agricultural types, knowing that, hey, the NAS drills down and provides some pretty detailed information about the types of crops that are on these lands. And so our ability to start to incorporate a seasonal element into these cropland types, where we know that early in the season, a wheat field, or a cornfield is just not going to be available completely, green. And then as time occurs, and we could see that, I think there'd be certain trends across the country based on, the environmental gradients, the precipitation that, they receive, that those fuels, and again, I'll call it fuels because it's just a different type of fuel, would become available. And so our ability to think about this question or issue a little bit differently and not just leaving it to, say, scientists, to kind of figure out, thinking about, a specific burn factor for, corn could be done. And we could do, I'll call it some rudimentary, work in that non-burnable area to help refine this. Because part of the problem with this is you don't want to make it completely burnable because then your entire landscape's, burning up. But at the same token, we do have the risk of, cornfields, wheat fields, things like that, do burn and are definitely problematic.
I don't want to put Daryn on the spot, but I also, I think folks might be curious to hear about, some of the challenges along the way for this new updating method for vegetation and some of the remaining challenges that we might, be looking for folks to kind of help us solve over the next few years.
It's fast. It's really fast. And so we're used to having more time with the models to come up, if things don't look right, come up with ideas. adjust them. We've been able to get decent models out, but some of them are, especially the ones where we just don't have a lot of training data are tough. We modeled at the VPU before, which was groupings of Amernic level 3 ecoregions. We had 13 of them across the country, so a little smaller, definitely smaller and more manageable. We're modeling at the geo area now, so it's a lot larger. We did that because we had the computing resources to do it, and we were hoping there would be more training data. Geo areas there's 6 of them across CONUS, and they're groupings of map zones, MRLC map zones. So different modeling boundaries and different results for that reason. And just, once you see the models and if they don't look right, try to figure out why. And then you have to come up with ideas on how to make them better. And sometimes you just run out of ideas as the clock's ticking.
Yeah.
So more plot data. And then, if anyone has expertise, ideas, have done vegetation modeling, and I can point us to resources. We're always looking for ideas on ways to improve. We're always testing and trying new ideas. So we're always looking for insight from users on that, feedback on their specific projects, things they're running into, observations they're making, things that might look off or questionable. All of that feedback is helpful for us. Just message that into the help desk, the LANDFIRE help desk, and we review that. You don't have to have questions. We really benefit from just notes from people on what they're seeing, especially if it's anything different than they've seen in the past. And if we get enough of those in a certain area, that points us to something going on. And because we don't have, of course, when you're mapping like this, you have limited ability to really zone in on certain areas. We can do broad scale accuracy assessments, but that doesn't always tell us what might be going on in a specific area, improvements you'd like to see. So we are all ears when it comes to that. The fuels connection piece is challenging because they use the severity assigned for the year of the disturbance. And we're not able to create that right now with vegetation because we're using, current year imagery, not imagery 10 years ago. So that's something that we're going to be looking into as well, so that we can continue to make that connection between vegetation and fuels.
And I think one of the ones that you already mentioned was sort of those more recent disturbances are challenging as well. Yeah.
Yeah. Yeah, I don't know where folks can help with that. I mean, I guess that just comes down to modeling and the things that folks are doing that, to work on that. But this is a chance to reinforce what training site data standard is. Definitely. We get field plots from all sorts of different sources and all sorts of different methods for collecting those plots. We try this, for example, tree cover, we just go with FIA, Forest Service inventory, the forest inventory analysis plots, because they have a reliable method for that. That would be great if, there could be a standard, but we try to extrapolate, especially the rangeland plots are oftentimes small. They don't really represent a 30-meter pixel. So that's a challenge. But there's always opportunity to converge on data collection. But I think we're really kind of moving in a direction where we can get that from LiDAR, so it's standardized. So I guess we're not really looking to field data collection as our key to the future, just because we know how challenging that is, expensive, limited in extent, and all of that.